तो बस इसके पास में क्वेश्चंस कर लेते हैं कि we had three types of intermolecular forces. One was dipoles, और dipoles में था it depended on the shape of the molecule, ठीक है, and it depended on the shape of the strength of the dipole, कि dipole कितना strong है. Sometimes the dipole would get cancelled out if जैसा CO2 का केस है, where the force of attraction and the shape of the molecule would cancel out the force of attraction. Sometimes it won't, just as sulfur dioxide, okay? So then you had hydrogen bonds, which were an extreme version of a dipole, where you had oxygen, nitrogen, or fluorine, which have these high charge density lone pairs. Because it's a small atom, so negative charge is very concentrated. The electrons are very concentrated, so the negative charge is very strong. And the other reason why the negative charge is strong is because they're highly electronegative as well. तो वो अपने electrons को बड़ा strongly attract पहले करता है, ठीक है? So it's extremely electronegative. So that would result in a dipole which would be very strong, where the positive H will get very strongly attracted to the lone pair of either oxygen, nitrogen, or fluorine. Or whenever you had hydrogen bonding, the molecules will have really high boiling points compared to similar molecules. इसके अंदर एक वो आ जाता है water की properties वगैरह के ऊपर भी question के. So water की a lot of properties of water apart from the higher boiling point compared to other similar molecules which are not actually, I mean, these are all gases. इसको अगर देखो H2S, that's a gas. तो इनके मुकाबले में इसका जो boiling point होता है that's extremely high, plus hydrogen bonding के साथ ना there were some properties associated with it, और अच्छा उन प्रॉपर्टीज को थोड़ा सा डिस्कस कर लेते हैं कि वाटर व्हेन इट फ्रीजेस इट एक्सपैंड्स, ठीक है, ये प्रॉपर्टी है. हाई सरफेस टेंशन, वो सारी चीजें इसके साथ एसोसिएटेड हैं. सो वाटर freezing leads to expansion. अच्छा, freezing leads to expansion, and the reason is hydrogen bonding, ठीक है. Water freezes, or what happens is that the crystalline structures follows the hydrogen bonds, or the crystal water aligns in solid state according to hydrogen bonds. यानी water का molecule होता है when it's liquid state, the molecules are very energetic and they can easily overcome the attractive forces. So when you have lots of water molecules, they can easily move around anywhere they like, and they will overcome all hydrogen bonds. They will not be it's not going to be determined by hydrogen bonds, but when it freezes, so ये जो molecule है, this will rotate and it will align itself wherever the hydrogen bond gets formed, ठीक है, wherever it gets attracted. When it loses energy, so all these molecules one by one, they're going to get attracted and they will align. So जो negative oxygen है, that will get attracted to the positive H every time. तो ये आपका positive H है, इसका lone pair है, that's your negative oxygen. ठीक है, this oxygen has its lone pair and it will get attracted to the positive H. It's got another lone pair, ठीक है. This is your positive H and it will get attracted to the lone pair. So that creates a lot of gaps. Okay, so this alignment creates a lot of gaps, which leads to expansion. अच्छा, तो इसी चीज को फिर लास्ट था कि the last one that we did was Van der Waals forces, which I told you that Dipoles, especially in molecules which don't have dipoles, the electrons, they fluctuate left or right. They get knocked to one side or the other side, creating temporary dipoles or instantaneous dipoles, which also leads to induced dipoles. Even molecules that already have dipoles, with their dipoles will also fluctuate. So they will also have van der Waals forces. HI ka molecule, the iodine ka molecule, the bigger the molecule, the more van der Waals forces it's going to have. Or shape of molecule के जितना उसका surface area ज़्यादा होगा, the more it's going to interact with other molecules, it's going to bump into other molecules, and it's going to lead to more temporary dipole, instantaneous dipoles. So that's one thing. और फिर ये कि इसे quickly थोड़ा सा past papers कर लेते हैं कि intermolecular forces के. Intermolecular forces. So starting with the first, why is for the last time नहीं किए थे. Starting with the first one, it's why is the boiling point of ammonia higher than the boiling point of phosphine? Ammonia, remember, is extremely polar. It's a highly electronegative N, and it's trigonal pyramidal. It's got a very strong partial negative charge and a very strong partial positive charge. So ammonia molecules will attract each other with very, very strong dipoles, which are hydrogen bonds in this case. So this can be negative part hoga, and they will strongly attract each other. So the answer to that is, why do they have higher boiling point? Because the ammonia molecules have significant hydrogen bonding. ठीक है? Clear है इमरान? ये clear है? Saad? Rafiq, clear?
Yes.
Yes.
Acha, next one is, in this question, X represents an atom of chlorine, bromine, or iodine. Which explanation for the variation in volatility? Now, chlorine is Cl2, bromine is Br2, and iodine is I2. Now, they all are non-polar, which means they will only have instantaneous dipole and induced dipole. So they will only have, the only force that's present is van der Waals forces. तो कभी आयोडीन का ये वाला पार्ट अच्छा कभी आयोडीन का ये वाला पार्ट स्लाइड नेगेटिव हो जाएगा, this side will become slight positive. Sometimes it's going to be the other way around, so it's going to be instantaneous dipole, induced dipoles. Which one out of the three will have the most van der Waals forces? छोटा, ठीक है, so it's iodine. So the bigger the molecule, you've got more electrons, so there's more fluctuation happening. So which is why you're going to have more van der Waals forces. Okay. So that's why volatility decreases down the group. Volatile ka matlab hai evaporate jaldi hota hai ki nahi. So iodine does not evaporate that easily. Chlorine is already a gas. So variation in volatility, the instantaneous dipole, induced dipole forces between molecules, that become stronger. So remember, volatility is, what is volatility? Volatility is the tendency to evaporate, let's say. Or you can say having low boiling points, or you change to gas easily. So the answer is, okay, it's going to be instantaneous dipole, induced dipole. Their forces become stronger. They don't have permanent dipoles. Remember, boiling points, they don't depend on bond energy, because when you boil a substance, you don't break the bonds. So जैसा water जो है वो steam के state में भी watery होता है. So you're not breaking the bonds. So then you have okay, electronegativity on the y-axis. So this one is going to be D, that it increases to the right of the periodic table. So across the period, it's going to increase. अच्छा अगला पार्ट है कि which pair substance have a lower boiling point than the first substance. वैन डर वाल्स फोर्सेस में पता नहीं हमने लिखा था कि नहीं लिखा था. वैन डर वाल्स फोर्सेस में remember that the carbon and hydrogen bond is non-polar. ये अलग से एक पॉइंट यहाँ पे लिख लेते हैं that the CH bond is considered to be non-polar. They have kind of the same electronegativity. तो आपका जो CH bond है is almost non-polar. So, which is why all organic molecules, carbon chains, have van der Waals forces only. क्योंकि dipoles तो है नहीं. So, alkyl chains, which are carbon chains. And since they are not they only have van der Waals forces. प्लस एक चीज हमने मेरे ख्याल से इसमें मिस की है वो ये कि ये इंटरमॉलिक्यूलर फोर्सेस से होता क्या है. तो लेट मी जस्ट comment on that. Properties that depend on intermolecular forces. So that अच्छा काफी properties depend करती हैं intermolecular forces. Even reactivity, even chemical properties are actually sometimes dependent on intermolecular forces. अब इसके अंदर ये कि what are the properties that depend on intermolecular forces? Number one is obviously your melting points and boiling points. So that's pretty obvious. कि भी ज़्यादा strong होंगे intermolecular forces, more energy would be needed for breaking them. Second is it depends, solubility depends on that. So solubility का rule ये कि like dissolves in like. I mean similar intermolecular forces or molecules having similar intermolecular forces will dissolve or mix with each other. So with intermolecular forces will mix. अब उसमें ये कि अच्छा molecules having similar intermolecular forces will mix. अब उसमें ये कि for example if you've got water, now water will dissolve ammonia. Why? Because water has hydrogen bonds and ammonia also has hydrogen bonds. And it's also having a lone pair with a strong negative charge, and they will attract each other. So similar will mix. Molecules, they will mix and they will attract each other, and so mixing will happen. Again, if one of them is polar and the other one is non-polar, then they're not going to mix. For example, carbon dioxide will not mix in water. Why? Because बहुत ही कम मिक्स करेगी. क्यों? क्योंकि वाटर का जो मॉलिक्यूल है that's highly polar, and if you've got a carbon dioxide molecule that's highly non-polar, it only has van der Waals forces. ठीक है, so this one is non-polar. So अगर पानी के molecules होंगे, so instead what they'll do is कि if they're two water molecules, they are more likely to attract each other instead of attracting the carbon dioxide molecule. तो इसका जो H है ना वो उसको जाके attract कर लेगा, instead of attracting this water molecule, no one attracts it. So they would form a separate layer. Same with oil. Oil will not mix with water molecules. So water will attract other water molecules instead of attracting carbon dioxide. So other water molecules instead of attracting this non-polar CO2. As instead of attracting the non-polar CO2. Now, अच्छा और क्या properties होती हैं? This अच्छा melting or boiling point से वो वही है कि volatility is often they use the term volatility. अच्छा फिर इसमें surface tension होती है कि ज़्यादा intermolecular forces होंगे, it's going to be higher surface tension. I mean, why do insects? Why are they able to? Why do you throw a stone and it bounces off water, right? Because the water molecules are forming a layer and they're all attracting each other very strongly. So the rock is not able to penetrate that surface because they're all attracting each other with strong hydrogen bonds. Viscosity, yeah, that's another thing. I said even reactivity, remember, is reactivity also that polar molecules are more reactive. One example is why does carbon monoxide cause poisoning? Because carbon monoxide is way more reactive because it's polar. The oxygen is slight negative, the carbon is slight positive. तो आपके hemoglobin के साथ जाके ना जुड़ जाता है. It eventually ends up forming a pretty strong bond. Oxygen molecules, they don't. इसलिए वो oxygen टूट के अलग भी हो जाता है because it's non-polar. It doesn't really stick that strongly. Carbon dioxide is also non-polar. So this one is kind of very reactive for hemoglobin and forms, you will see example है, ठीक है? अच्छा, it's very reactive for hemoglobin and binds very strongly to it, ठीक है? ये सारा clear है?
Yes.
अच्छा, वापस इस पे आ जाते हैं. Remember, carbon and hydrogen bonds they don't. So the first one over here is non-polar. जो C2H6 है. This one is polar because it's got a Cl. So Cl will try and attract electrons towards itself. तो इसकी वजह से ना molecule की ये वाली side negative हो जाएगी, the other side will become positive. And this one will be non-polar. But it will only have van der Waals forces, which is why the one that has a lower boiling point is going to be. In which way does the second substance have a lower boiling point? This way, the second one has a higher boiling point because it's got a dipole. अच्छा, इसके अंदर भी जब O और H इकट्ठे bonded होते हैं ना, so इसमें क्या होगा? It's one molecule is CH3 OCH3, right? And the other one is C2H5OH. So that's ONH. ONH इकट्ठे होंगे ना, so that will result in hydrogen bonds. So that results in hydrogen bonds. दो H है. Carbon की change हो, that's non-polar. And this one does not have hydrogen bonds. Why? Because the O has to be directly connected to H, where over here it's not. So इसमें भी ना ये इसके boiling point जो होंगे ना, that's going to be higher. As a third one, neon and argon, they both have अच्छा, both have van der Waals forces क्योंकि obviously non-polar है क्योंकि there is no difference in electronegativity. It's just an atom. Both have van der Waals forces, यानी random fluctuation चल रही होगी in its electrons. Argon is bigger. So hence, it's going to have more van der Waals forces. The answer क्या होगा? Last वाला ही होगा. This one has hydrogen bonds. This one over here is non-polar. And it only has van der Waals forces. So the answer will be D. ठीक है, clear है?
Yes.
Which statements are correct? The hydrogen bonds in ice are more regularly arranged than in water. That is true. We just did that. ठीक है कि ice के अंदर जब formation हो रही थी ice की तो the water gets यहाँ पे था कि when water freezes it leads to expansion. Why? Because it creates a certain alignment where the water molecule get very regularly arranged. So अच्छा, solidification of water to form ice is exothermic. That is obviously true. कि मतलब ice बनती है तो exothermic process है. Pure water is less dense than ice. That is, pure water is less dense, needs more dense. So this one is wrong. Ice jogi, ice is more dense. Sorry, ice is less dense. Why? Because what is density? Density is proportional to mass over volume, right? So mass वही रहता है, but when ice forms, the volume increases, right? So which is why the density decreases. So ice is the one that's less dense. So which solid contains more than one type of bonding? उसका answer A है कि iodine has covalent bonds, and at the same time it also has van der Waals forces. तो बीच में you've got van der Waals, and you also have covalent bonds. ठीक है. Zinc जो है ना, zinc is only metallic bonding. Sodium chloride is only ionic. Or silicon dioxide, अगर वो giant covalent structure, if you remember SiO2, that's only covalent. Actually, remember this thing that in giant structures, all of them, metallic, giant ionic, and giant covalent, they don't have intermolecular forces. Metallic bonding में is just one structure. Intermolecular forces is always between molecules, small molecules. So metallic and then it's just a bunch of metal ions in a sea of free moving electrons. SiO2 का अगर covalent structure होगा तो it's only going to have a mesh or a network of very strong covalent bonds. That's it. वो बस endlessly repeat हो रहा होगा. ठीक है, that's what it would look like. तो सिर्फ covalent bonds होंगे. Similarly, ionic, only ionic positive ions attracting negative ions, and that's about it. So giant structures, they don't have, there's only one which has intermolecular forces. What is a giant structure that has intermolecular forces as well?
Graphite.
Yes, graphite. It has two separate sheets, and those sheets, they get attracted to by van der Waals forces. So only that. Say अगला वाला, which molecule has no overall dipole? Now, the first one definitely has. क्या आंसर होगा इसका वैसे? मतलब ये साइड, which one doesn't have dipoles?
ये होगा. D होगा. D.
क्या होगा? A?
No, D for dog.
ठीक है, CCl4, it will have एक तो उसकी शेप भी सिमेट्रिक है कि ठीक है, so all Cl's dipoles will cancel out, ठीक है. All Cl's will try to attract electrons in different directions, but since they're attracting electrons with the same force, the dipoles will cancel out. अच्छा, वो कह रहा है कि ethylene glycol is used as a de-icer. It allows ice to melt at temperatures below 0 degrees centigrade. तो अच्छा, below 0 degree centigrade. तो इथाइलिन ग्लाइकोल है और उसमें OH के ग्रुप्स हैं. So it allows ice to melt. Ethylene glycol changes the extensive network of hydrogen bonds in ice. अब ice में क्या था कि ice में you had water molecules very strongly attracted to each other, ठीक है? There was this positive H attracted to the negative O between them. So what will happen is that if you add ethylene glycol, why is it a de-icer? Will it form hydrogen bonds with ethylene glycol को अगर add करोगे ना ethylene glycol में you got OH and you've got CH2 and you've got CH2 and then you've got OH again, right? So ethylene glycol itself can form hydrogen bonds. So will it disturb the extensive network of hydrogen bonds? It might. कि उसका जो H है ना उसको वो अपनी तरफ attract कर सकते हैं instead of the water molecules getting attracted to it. So it might break those hydrogen bonds. Is that idea clear?
Yes, sir.
So it will do that, which is why the water will melt. Okay, the hydrogen bonds in ice will break and will break more easily. So ethylene glycol molecules form hydrogen bonds with other ethylene glycol molecules. That's obviously true because ethylene glycol can form hydrogen bonds. So it not only will it form hydrogen bonds with water molecules, but it will also form hydrogen bonds with other ethylene glycol molecules as well. Ethylene glycol molecules will dissolve in the water. Yes, it will dissolve because they're going to mix together. They attract each other, right? So they will form hydrogen bonds with each other. So with each other. So the next one, which molecule has the largest overall dipole? So, which one has the largest overall dipole?
एक सेकंड. ऑप्शन बी होगा.
Option?
B for ball.
ठीक है, क्योंकि उसमें there's an oxygen. अच्छा, and that oxygen is pulling electrons in one direction, ठीक है? तो इसलिए वो oxygen जो होगा ना, that's going to be slight negative, and the other ones are non-polar. यहाँ पे the dipoles kind of get cancelled out. ठीक है, so dipoles cancel out in this one. Either way, dipoles kind of get cancelled out because the Cls are pulling electrons in opposite direction, and this is exactly the shape of the molecule. So दोनों cases में dipoles get cancelled out. इसके अंदर it never had dipoles to begin with. So no dipoles to begin with because carbon and hydrogen have similar electronegativity. बाकी भी पूछ रहा है कि हाइड्रोजन बॉन्डिंग की वजह से क्या होगा. Obviously water has a higher boiling point than H2S because ice floats on water. That's also because of hydrogen bonding. Bond angle hydrogen bonding determine नहीं करती वो तो. It was the repulsion between the bonds. So the other ones are okay. Part of the structure is polar and is water attracting. So it is polar. Part of the molecule oxygen -1 and Na +1, so it is polar. But it's highly polar. It's full negative charge. Alkyl chains, remember, our carbon chains are non-polar. So they attract oil droplets. They do because oil is also non-polar. Non-polar attracts non-polar, or non-polar mixes with non-polar. अच्छा एक तो ये हो गया थोड़ा सा वो उसके क्वेश्चंस देख लेते हैं कि थ्योरी वाले जिसके बस वो ड्रॉ करें वो क्या आएगा. अच्छा ये सारे शेप्स के हम पहले ही कर चुके हैं. अच्छा explain why the melting point of SiCl4 is higher than that of PCl3. तो SiCl4 ये है और PCl3 is this one. Which one is polar and which one is non-polar? और ये दोनों की शेप बनी हुई है.
Sir, right वाला polar.
Actually, this one is polar, right? Most likely it's the Cl part which is slight negative because it's more electronegative. So this one और ऊपर ये वाला positive हो जाएगा. So that's your polar. तो किसका boiling point high होना चाहिए? मतलब जो polar है उसी का होना चाहिए ना high. लेकिन वो कह रहा है कि लेकिन वो कह रहा है कि इसका high है. Why? What is the reason for that? Why does it have a higher boiling point? इसके पास कौन सी intermolecular forces है ये वाला जो है SiCl4?
Permanent dipole. Permanent dipole.
नहीं van der Waals forces होगी क्योंकि dipole तो cancel out हो जाएगा.
Oh जी sir.
But ये तो completely non-polar है, so only van der Waals forces, right? Van der Waals forces ज्यादा कब होती हैं? Bigger molecules have, remember, bigger molecules have more van der Waals forces, ठीक है? So whenever you have bigger molecules, you have more electrons, so there'll be more instantaneous dipole induced dipoles. तो आपके पास इसलिए इसका बॉइलिंग पॉइंट हाई होगा. रिमेंबर वैन डर वाल्स फोर्सेस बहुत वीक भी होती हैं, बहुत स्ट्रांग भी होती हैं. इट डिपेंड्स ऑन द साइज ऑफ द मॉलिक्यूल. So the only reason, although this is non-polar, but it had van der Waals forces. अच्छा उसी तरह उसने वो कहा है कि volatility explain करो down the group. So same thing. मतलब जो ऊपर लिखा है वो नीचे लिखना है कि bigger molecule you have got more electrons. So hence there's going to be more instantaneous and induced dipoles. और इसकी वजह से क्या होगा कि you'll have more van der Waals forces. वाइस के मॉलिक्यूल्स ड्रॉ करने को कह रहा है तो वो सिंपल उसको ड्रॉ कर लो कि 104 डिग्री का एंगल होगा. दिस इज नेगेटिव, दिस वन इज पॉजिटिव, this lone pair is negative, and there's going to be another water molecule. तो इनके बीच में there's going to be attraction. तो उसको लेबल कर देना कि this is the hydrogen bonds. चलो ठीक है, कल पे हम सिग्मा पाई बॉन्ड्स करते हैं. इंटरमॉलिक्यूलर फोर्सेस हमने कर लिए, तो ये कल कंटिन्यू करते हैं. ठीक है,
ओके.
चले, ओके, अल्लाह हाफिज.
अल्लाह हाफिज.